Welcome back. In this video I'm going to take you through a greenfield build of a new architecture along with the do's and don'ts of ADC networking architecture. So let's talk about option number 3. The last option, option number 2, is probably about as good as you're going to get for a pre-existing network without having to have people do major surgery in their architecture. But you never know. Sometimes people will let you make bigger changes, and option number 3 is basically the same as what we would do in a greenfield build. So option number 3 has one other characteristic, and that it is the preferred option for a VPX regardless. So when you have a VPX, in order to achieve maximum throughput, the preferred method is always to use 3 interfaces on each VPX across 3 different subnets and VLANs. One interface is for management traffic, one interface is for externally accessed VIPs, and one is used exclusively for traffic to and from the back-end applications and servers. This is the preferred architecture for VPX appliances for reasons that would take way too long for me to explain in this video. But similar to the issue of not having a separate routing table for management traffic, this is due to an architectural detail of the ADC software and how multiple CPUs and multiple packet engines in an ADC are handled. Another detail that we may agree or disagree with, mourn or complain bitterly about, but we're stuck with it. So for now, just remember, maximum throughput on a VPX is achieved with at least 3 different interfaces on 3 different subnets. I decided to add some more detail to the drawing. So here we have public internet, there's the firewall, inside interface is 192.168.2.1 connecting to VLAN 2, which is the default route from the ADC. There's your management network. We've got 3 management IPs, 2 NS IPs, and a management SNP. There's your VLAN 2 SNP, VLAN 4 SNP. That's the route to VLAN 3 through 192.168.4.1. And down at the bottom, you've got all of the real server IPs for this lab. 2 brand new NetScalers, cleanly built, no configuration. All right. So I think the first thing we will do is go and change the NS IPs so that they're secure access only. Network IPs on both sides. All right, so we'll just go in here and edit, go down to the bottom, and secure access only is already checked off, so we are good to go. We'll do the same on the secondary. And it's also checked there. Good to go. All right, now we can go back and we can place these 2 ADCs in high availability. There you go. On the secondary unit here, we're going to configure that guy, change that status to stay secondary. Click the failsafe mode and click OK. Go to the primary, edit, set this one in stay primary. We already clicked failsafe mode, click OK. Alright, so the high availability is ready to be configured. So we just add the second node to the first, put in the credentials. We'll take the secure access box and create. All right, we'll just refresh until that in progress on synchronization state changes to success. There we go. We'll save it. All right. We'll save it on this side. All right, so the next thing we're going to do is we're going to go down to network and RPC. So remote procedure call is used to communicate between these two nodes. And we're going to modify it so that all the remote procedure call traffic is encrypted. And we're going to change the password used for that. So we changed the password. We made sure secure is ticked off. We'll say OK. Now we'll go to the second RPC node. We'll change the password there. We just don't want to use the default password. Click secure and OK. All right. Then we're going to go to the secondary node and we're going to network RPC. We're going to do the same thing. I believe that this propagates with HA, but just in case, we'll set it on both sides. Putting in that password. Secure is already ticked off. Say OK. We'll do it on the second one. Same password. Secure is already ticked off. Okay. All right, so now these guys will be communicating in HA over encrypted protocol using a different port. So now we can go back to high availability. We'll go to this secondary, and we are going to modify this guy to be an enabled state. Say OK. And we go back to the primary and look at it. We do the refresh, you can see it's the other one's there. We're going to edit this one and put it in enabled. Say OK. All right, so the HA configuration is complete. Just save it on both sides. And I believe from here on in, we don't need to do any configuration from the secondary unit. All right, next step is we are going to add the subnet IPs, and we're going to add first a management subnet IP. This is useful for managing the units, so you can go to this 1.44, and whether there's been a failover or not, you're always going to land on the active unit. And this will be used for management, so we'll take secure only and create. All right, so now you've got a management subnet IP. Now we'll add the one for VLAN 2, which will be 2.44. We'll go down to the bottom here, and this does not need to have management enabled. All right, so we've got that IP address. And this one will be 4.44 for this VLAN 4. And create. Okay, so now you've got all your subnet IPs. And 1.44 is for management. Alright, now we'll create the VLAN. This is going to be VLAN 2. We'll call this DMZ-EXT. Alright, and this VLAN is going to be bound to interface 1.2 and the subnet IP 192.168.2.44. Just so you can see, we added in that alias name so you can see it. VLAN 4, this one will be DMZ-INT. Bound to interface 1.3 and 192.168.4.44 will be the IP address on that VLAN and interface. Okay, so the next step here will be put in the PBRs, but first I'll show you the existing route table. Currently the route goes out 192.168.1.1. That's because that was the only address on the box when we started. So, seen the PBRs before, that's a friendly name. Choose new there. The next hop's going to be the same as the current default gateway, 192.168.1.1. Now we're going into this configure IP section. So this would be for source IPs equal to 192.168.1.42 through 192.168.1.44. Alright, and destination IPs will be any IP not equal to, we'll start the low range 192.168.1.0 through 192.168.1.255. Alright, hit create. Now we'll go up to select action and we'll say apply. Alright, so now your traffic to and from management IPs will use that policy-based route. So what I'm doing here is trying to trick the GUI into updating, hits on the PBRs. You can't always trust what you see in the GUI. If we go back and look, hopefully it will register some hits, but if not, I'm still sure that we're doing okay. All right, it still doesn't show any hits, but we're going to actually move on from here. Let's go to routes. We're going to add new default route, the one that will stay with us, 0.0.0.0.0.0. This gateway will be 192.168.2.1. Alright. And we can remove the old default gateway because it's no longer needed with the PBR. And back to GUI problems again, doesn't update. If we go back to routes, we should see now we just have one default gateway. And we're going to add a route to the 192.168.3.0/24 network. And this will go through VLAN 4. Gateway will be 192.168.4.1. Alright, so there you see it's the last one in the list. So we have our routing in place. we go back to the PBRs. Alright, so we've got some hits now. That's what I was trying to see before. Save that config. Alright, other things we set up when we first start. We got NTP. The issue with this Ntp configuration is those are all DNS names, and we don't have a DNS resolution set up on this ADC yet. So in order to get NTP working with those NTP servers, we need to modify our DNS configuration. We're going to set up a load balanced DNS server, so we need to enable load balancing. And while we're here, we'll go ahead and enable SSL because we know we're going to be using it later. So we got the load balancing enabled. All right, go ahead and here to servers. We need to add the internal DNS server we're going to use. So this name can be anything. I have it match the server name. I believe that address 192.168.3.11. Alright, so we got a server created. The next step for us would be to create a service. Another friendly name, but it can be anything you want to try and make it something descriptive. So DNS UDP service. We'll use the existing server we created. We're going to choose DNS service type. Say OK. Let's go down to the monitor, and we're going to add a specific monitor for DNS traffic. And let's edit that monitor. Alright, for the query by default is dot. We're going to change it to the actual name of a server we want to look up. postcon-ad1.pc.local. And that DNS server should respond with 192.168.3.11. So we've modified that. Now we can bind it, and it's working because you can see we got response code 0, which means we saw what we expected. We'll add a second service for TCP DNS. It's not used very often, but when we have very large return, it'll switch to TCP. We'll use the same monitor for this one, DNS monitor we just modified. You can see we got a good response. So we got 2 DNS services, and now we'll create a V server for it, one for UDP and one for TCP. The protocol there is going to be DNS. IP address type is going to be non-addressable because this is only accessed from inside the ADC. We'll bind the UDP service we created. Alright, so that's bound up, and I believe if we just say done, see that guy is active and working. Now we'll do the same and create a TCP version of this. need to change that protocol to DNS-TCP or underscore TCP. Also non-addressable. Alright, let's bind the TCP service to it. And here we can click continue. And go down to the bottom and say done. Alright, so we got a TCP and a UDP DNS load balance vServer. So now we'll go down to DNS. I think I missed it there. There we go. Name servers, and we will add name server, choose DNS virtual server, and we can choose the UDP one. That means the protocol will be UDP. And we'll add the TCP version also, in case we get some large response from DNS. Alright, so now we have DNS resolution. And the whole purpose of that was to make sure we could actually resolve the names for the NTP servers. So what I'm going to do now is bring over a command line and let's check the status of NTP. NTPQ minus N. Let's run PE. So we're talking to those servers. AS. We're actually already in sync with them. So we know that DNS and NTP is working. Now we've got this basic configuration. We have no load balancing other than the DNS load balancing we created. And the next step for us is to add in the remainder of the load balancing configuration. And we'll use a script for that. So I created the file ns.conf.new with all the command lines I want to put in, and the output of that script will go into outfile.txt. So from here we need to exit, and I'm going to do batch minus file name minus file name /var/temp/ns.conf.new minus outfile /var/temp/outfile.txt. Now I just put in a whole bunch of lines very quickly. We just need to save the config. You do a show IP, you can see we added in a bunch of new VIPs. Everything from this perspective looks good. We'll go back to the GUI. And let's go look at load balancing, virtual servers. Okay, we got AP1 LBV server, AP2 LBV server is down. All of the services are up. I believe my script probably forgot to bind the certificates to these guys. Yeah, that's right. No server certificate on a SSL vServer. So that one take AP1 or API1, excuse me. Done. It already shows up. And we'll bind the API2 certificate to this guy. And all right, everything's up. Everything looks good from this perspective. let's go and open the browser and actually try and reach one of those load balance guys. 192.168.1.52, and there you go. We can reach it, and everything looks good. So let's save the configs. And basically we've got this architecture in place, exactly what we started out to do. Let's review what we've done here. First, you're looking at a slide of the traffic flow and the remediated architecture for the customer. This is a perfectly serviceable architecture and meets all the customer's goals. More importantly, this remediation can be completed with a minimum of involvement from other teams. No cable pulls and only a simple VLAN change on a switch interface. This architecture gets the job done. In this slide, we are looking at the traffic flow for the Greenfield architecture we just put together in this video. The diagram certainly looks cleaner and is easier to follow, but be careful about thinking that this is any simpler to implement than the remediation. This architecture will require at least as many firewall rules as the other, and it takes as many steps for a round-trip web request as the other. The difference is that this architecture has 2 firewalls instead of 1, and even that is not entirely true. While in the drawing we showed 2 firewalls, this same traffic flow could be completed with a single firewall with a presence on all the relevant networks or subnets. Some security departments require separate physical or virtual firewalls for each of the functions we show here, but others do not. The important thing about this traffic flow isn't the number of firewalls, but the number of firewall rule sets and networks that the traffic passes through. The purpose of this architecture isn't to provide additional security. The purpose of this architecture is to increase performance and throughput. Specifically, it improves performance on VPX appliances, but it also may improve performance on a hardware device if the throughput on interfaces is reaching critical limits. One of the nice things about this architecture is that it can be expressed in an easy to understand drawing. Now, this may not be important to you because you already understand the flows, but keep in mind that most likely you won't be the only person working on this. Ease of understanding for people with less experience has a second-order effect of being less likely to be broken by people who don't understand. Before we finish this video, I'd like to summarize a list of do's and don'ts for building a new Greenfield ADC implementation. So when we're building a new infrastructure, we have the benefit of building it the best way from the start. So here's a list of do's. Use 3 separate physical or virtual interfaces minimum. You got client-facing outside, server-facing inside, and a management interface. Place the interfaces on separate VLANs with separate subnet ranges. Create a SNP for each VLAN interface. Send the default route towards the public internet. That's where your unknown networks are. Use a policy-based source route for management traffic. And use static routes for traffic to real servers and applications. Alright, so here's the don'ts. When you're building from the ground up, don't use NSVLAN. I'm not going to spend the time to explain what NSVLAN is in this video. Just understand there is no corner case where NSVLAN is required. The feature should probably just be removed. Don't use MAC-based forwarding. That's the general rule. You're going to know if you're in the corner case where this is necessary, and then you turn it on. But otherwise, leave it turned off. Don't use the one-arm network configuration. The time when you can use it is when you have low throughput and you're confident that all of your equipment can handle it. But if you need to maximize your throughput, don't use a one-arm configuration. And don't use dynamic routing. If you have to, it's just like the other. You'll know you're in that corner case and you turn it on. But why take the risk of accidentally inserting routes into the customer's network that could harm things well beyond your ADC implementation? This architecture has come a long way from where it started and will function properly now. You've had a chance to learn the basics of building a good foundation for your ADC configurations and learn some of the how and why we build these ADC appliances the way we do. If you build a strong foundation, you can focus more of your attention on the trickier details of load balancing, advanced authentication, payload manipulation, and other functions of an ADC when it comes time to build them. This is the final video in this series. Expect more to come in the future. If you find this interesting and would like to learn more, subscribe to our channel for more instructional videos. If you have suggestions for additional topics you would like to see, please let us know. We would love to tackle tricky problems in technology you may have encountered. If you need help with your organization's technology challenges, please visit our website at positive-convexity.com and get in touch. Thanks for watching.